So today's lesson is going to be stuff you already know. It's just algebraic expressions and formulas. So like you'll see a lot of x's, see a lot of y's, maybe some z's. I don't know. So just do a quick warm up while I get some water. Okay, I'm back. How you guys doing? Oh, I got a lot of answers. Okay. Is my doing bad? Why are you doing bad? Is my video not working again? I've given up at this point. I can't get it to work. That's fine. That's fine. If you're not done. But yeah, I've given up at this point. So Okay, I'm seeing a lot of good answers, so you guys are good. I can't confirm each answer one by one, but you'll see the answers by the end. Don't worry. So I'll give you guys a couple more minutes, or actually, I'll end it whenever I want. But yeah, you guys got time. Don't worry. Oh yeah, for number 8, let's see. Should see it's a proportion. I just rewrite it again. That's horrible, oh my god. But yeah, I just rewrite it again because you guys don't like the fractions like that. So 2/10. There you go. Yep. Number 9 is pretty easy, just an exponent property slash rule. Or you could do it manually, but if you know your exponent rules, you do it real fast. And everything else is just simple arithmetic. Nothing special, nothing fancy. By the way, how to solve faster for multiplication? You just gotta keep practicing. You have to know your multiplication tables and just gotta keep practicing. Yeah. I mean, maybe you could look on YouTube, like quick ways, but I mean, I was taught traditionally, you just gotta know your stuff. Gotta know it real fast. Don't worry though. When you get older, everyone uses calculators, and let's be real, the higher up it is in math, the less numbers you see and the more letters you're gonna see. You're not gonna see any numbers at all. Higher level math. It's crazy, I know. Just x and y's. Yeah, basically, you're gonna be seeing a lot of like d dx x squared equals 2x. Like there's only one number in that entire thing, and this is a mathematical statement, by the way. So yes. Well, it's two numbers, 2x and x squared, but yeah. So yeah, the higher up you are in math, the less numbers you really can see, and they're just gonna let you use calculators more. Let's see. Okay, got a few people finishing up, but I think for the most part, I'll give you guys a couple more minutes. I am lagging. Or are you lagging? Because I'm fine. Your screen share is still laggy. I hear your voice just fine. Oh, that's just how Zoom is. That's it. Zoom has like a horrible bit rate, so you can't do anything about that. That's just Zoom. You're close, Zoe. Not quite though. Close for number 8. X has to be 0 for the algebra thingy. Which one? There's 2 of them. This one cannot be 0 because you cannot divide by 0. That is very highness. It's a very highness thing if you do that. And this is clearly not 0 because 4 times 0 does not equal 16. That's what this means. 4x equals 16. 4 times y equals 16. And this means 98 divided by x. No, not that thing you just erased. So x has to be 0. Oh, this thing? This is something else. This is totally different. This isn't, yeah, this is nothing related to what I show you guys. This is totally different. Don't worry about this. This is oh, what did people invent maths? You tell me. You tell me. I forgot how to do cubic. How do you do cubic? This isn't, you don't have to simplify. Okay, well you could, but this is an exponent property. 2/3 divided by 2, or 2 to the 3rd divided by 2 to the 5th, because they want to torture kids. If that's how you see it, I guess. This is an exponent property. Remember, when you divide exponents with the same base, you subtract them. It's an exponent property. There you go, Zoe. Yeah, number 8 is right. Or if you memorize 2 cubed and 2 to the 5th, yep. Okay, I think we're all good. Here you go. Here are the answers. You guys a little bit check it, I guess. If you guys want me to do one of them, you can ask me. Are the answers correct? Yeah, this time I'm 90% sure that's the correct. Okay, I'll do them right now. Let's see. Yeah, that's right. That one's right. That's right. That's right. That's right. That's right. That's right. Yeah. How was number 381? Let's just do it. All right, so 89, you could round to 90, but it's not 90, so you put 7 here, because 7 times 90 is 720 exactly. So 7 times 9 is 63. There you go. 7 times 8 is 56, plus 6 is 70. Oh, it's a little too much. Wait, 62. Yeah, that's right. It should be 80. My bad. Because that's still a little too small. Because okay, let's do this again. I'll show you. 89, 720. Okay, so you know 90 times 8 is 720, right? But this is not 90, it's 89. It's close. So you can put 8 automatically. So 8 times 9 is 72. And then 8 times 8 is 64, plus 7 is 71. You get 89. You put 1 right here. So I take 81. Everybody got the right answer? Okay. All right, let's move on. We good? Typed the wrong thing? Okay. That's good. I might skip this. I mean, if anything, do number 2. Number 1, you don't have to do. So number 2, 70 feet above sea level would be plus 70 because you're above, so positive. 40 degrees below 0, negative 40. Yep. A withdrawal of 40. Withdrawal means to take out money, so technically it's negative 40 because you lost 40. Should have said the bank account. And opposite 23 kilometers, yeah, plus 23. So yeah. And number 1 is just that. Oh, number 2, I took out. All right. Algebra. You guys know what algebra is. So algebra is kind of like a puzzle. Formal definition is, yeah, you don't have to do it, don't worry. Formal definition is, it's the study of using and changing variables in different equations in different ways. And we already know what variables are. It's a symbol, letter, picture, etc. There can be one or more numbers. Yes, one or more. Yes, that's true. Something that tortures kids. Okay, so x equals 15, s equals 2, y equals 3, and star equals 1. These are all perfectly valid variables. So x is a variable, s could be a variable, y could be a variable, star could be a variable. Your favorite subject is algebra. Algebra is not a subject. Okay, you're already learning algebra 1. I'm not gonna lie, I don't know what you guys are doing here because this is past that, but hey, that's past. An equation is 2 expressions that are shown to be equal to another, as shown by an equal sign. So equations must have equal signs, obviously because it has the word equals in it. Equation. An expression is almost like a sentence, and there are numbers, symbols, and operators grouped together, but without the equal sign. So example, 4x is an expression because there's no equal sign, and 2x plus 1 is also an expression. But if you did like 2x plus 1 equals 3, that's an equation because that's a statement saying 2x plus 1 is equal to 3. That's why you have the equal sign. Okay. And this lesson, we learned about algebraic expressions. So like these ones, these are algebraic expressions. Expressions with at least one variable. So basically expressions make equations. And equations, all you just gotta do is have an equal sign and have 2 sides. And that's how you have an equation. Okay. So let's take a look at this expression, 3x plus 2xy. This means 2 times x times y. This means 3 times x. Minus parentheses 2 times 3 parentheses plus 4y divided by x. So this can be written like this. 2 times 3. This dot right here is another way to signify multiplication. I've told you guys this already, but if you didn't know, well, now you know.
Are we just simplifying their expression?
Yeah, I'm teaching you guys how to simplify because some people might not know.
Oh.
All right, so let's try to answer the following questions. How many variables are in this expression? Well, to answer that, you already learned that? Good for you. Well, there's 2 variables, x and y. That's the only variables you see, x and y, right? X, y is not a variable. Well, they are variables, but yeah. X, y is not something.
Isn't x, y just x times y?
That's exactly what I said, yep. Okay, let's try to answer the second question. How many terms? So what exactly is a term? Well, term is any part of expression that is getting added or subtracted. So how I learned it is that you box your terms. I'll make this cleaner later, but I'll show you. And so in other words, there are parts of the expression that are separated by either an addition or subtraction sign. So when you multiply numbers together, those aren't separate terms. That's all one big term, multiply or dividing numbers. So 4y over x is one big term. That's a term. So yeah. So in the above expressions, there are a total of 4 terms. Can you guys see them? I'll erase this real quick. So in this expression right here, there's 4 terms, right? So you got the 3 times x, then you got the plus 2x times y, that's 1 term, because this plus the addition right here separates the 3x and the 2xy, minus 2 times 3. Well, 2 times 3, you can simplify to 6, so that just makes it 1 term. Plus, there's no addition or subtraction in the middle of this. Like I said, multiplication, division, they all make one big term together. So 2 times 3 is 1 term, plus 4y over x. Remember, multiplication, division, one big term. So there's a total of 4 terms. So 3x, 2xy, negative 2 times 3, which is the same thing as that, which equals -6, and 4y over x. Yep. Any questions? I think we're good. Okay. So, like I said, clarify definition of coefficients and different ways multiplication can be written because it can get confusing for some people. So coefficient is a number that is multiplied by a variable. X plus 2x. Yeah. Equals 3x plus x. Yep. Okay. So looking at expression, notice how these numbers behind or in front, I don't know, they call it in front, but they're basically behind. These numbers behind are coefficients, right? So you see them, the 3 and the 3x, the 2 and the 2xy, and the 4 and the 4y over x. This doesn't have any coefficients because that is a number. It has no variables. Yep, 3, 2, 4. And notice how they go in front of the variable. No one writes this, okay? No one writes x3, y2, xy2. No one writes that, okay? If you write that, it's going to be really, really unclear. Okay, no one writes that. Don't write that. Why thought? What is a coefficient again? So coefficient is a number that is multiplied by a variable. So the 3 is the coefficient. So if you had 3x, the 3 is the coefficient of the x. That's what they say.
Oh.
Yep. Or 2xy. It's just a number. It has to be a number. Okay. So 2xy.
Wait, so if you had 3x, the coefficient would be 3?
Mm-hmm. That being said, the coefficient of x, what would that be? What do you guys think?
X?
Not quite. Coefficients are numbers, not variables. Yeah, 1. There you go. Coefficient is 1. 1x equals x. Yep.
Okay.
Let's erase this. And like I said, they have to go before you write the variables, put the coefficient first. Don't write x3, write 3x.
Wait, x3 is x to the power of 3?
This is x to the power of 3. This is x cubed, which equals x times x times x.
Times x, yeah, I know.
But I'm saying write this, x3. Okay.
Like, what is x3?
It's the same thing as 3x, but don't write it like this. Do not write it like this. This is a no-no.
That's not how I learned it. I learned it 3x, not x3.
On the keyboard, x to the y power. Yeah. Don't, exactly. I'm telling you guys, don't write it x3 because I've actually seen some people do that because they're lazy. So they're like, oh, I write the number, I write the variable and then the coefficient after. I'm like, oh, I'm lazy. So yeah, don't do that. You do that.
What's the difference?
The placement, and it just makes the equation look ugly.
Like, no, like what's the difference of being like if lazy people did x3, wouldn't be the same to write 3x?
It's the same thing. Yeah, it means the same thing, but just doesn't look as clean. And everyone's gonna look at you funny because everyone's gonna be writing 3x. I mean, if you want to write x3, I guess more power to you, but then you probably appreciate why you don't want to write that, maybe. Okay, so there's 4 different ways of showing multiplication. So let's use x and 3. So there's 4 ways. 3x, you put them together. 3 times x with the x as multiplication. 3 dot x, which is same thing as multiplication. So this dot also means multiply. And 3 parentheses x, which also is perfectly valid. So the most common way is 3x, like I said, and 3 times x. Although this is not as common. This is a little bit ambiguous right here. And very quickly, you see why this part, the 3 times x with the x as the multiplication, is super confusing straight off the bat. You see very quickly right here, this part. That's pretty confusing, right? Because that looks like 3x squared, just not simplified. So the best solution is to just don't write it like that, right? Because you have this part right here, the 3x. You don't need the times, the multiplication symbol at all. Yeah. But the x in the middle of the 3 and x won't be confusing. Why not? See, if I put this, if I type that, most people, 99.9% of people who know algebra and stuff would write this as 3x squared. But you know this means 3x. You want it to mean 3x, right? 3 times x is better written as this way, or 3 times x, or 3 times x. These two are the most common. This is I said this is more common, but this is just more clear. But these two are more common, 3x and 3 parentheses, x parentheses. This is a no-no. Do not do this. Big no-no. Don't do it. Just don't do it, okay?
Do not do what?
If you have a variable x, don't write the x, the multiplication x, right, for x. Don't do that. Like right here, this part right here.
Wait,
bottom, right?
wait, isn't 3x 3 times x?
Yes, but don't write it like 3 times x. Just write it 3x.
Well, yeah.
Because that looks confusing,
Well,
right?
it would look like 3xx, which is 3 to the power. Wait, 3. Whatever. Probably 4x, but.
4x. Okay, well, okay, here. Let me erase everything. Okay. If you wrote to me 3xx, right? I would write this as 3x squared. But then you'd probably be like, no, I want it. That means I'm supposed to mean 3 times x. But I'm like, that doesn't make sense because this means 3 times x, which is 3x squared. That's the exact definition of that. So
wait, is it 4x or 3x squared?
3x squared. It's 3x squared.
Okay.
Why can't we just make it 3 times 3? Okay, that's also another thing because x is a very common variable. So Jenny asked, why can't we do 3 times y? Well, I would think this means 3 times x times y, right? Because x is a super duper, it's like one of the most common variables out there. It's like the go-to variable, x, right? Not a, not b, x. X is the go-to variable. That's why when you're writing variables, don't use the x, the multiplication x to write it because it makes it look super duper unclear. Because now I'm thinking there's 2
If you
variables.
wanted to do multiplication, can't you do that little dot thingy?
Yeah, you could do dot, yeah. So if you want to do that, don't make it equal. 3 times y. Let's just pretend the x is multiplication. You need 3 times y, but the most common way is just 3, the coefficient, and then the variable. Don't add anything in between, just write them together. That's the most common way. You guys ever seen this before?
Huh?
Have you guys ever seen this before?
Yeah. I had a few weeks ago, I ended a class from a neighborhood tutor, math tutor.
Okay.
So,
But
yeah, he's going into like 11th grade or something. Teaching me Algebra 1, so.
Good. So yeah, it's not really that confusing once you get hang of it, Zoe. Just write this, okay? Whenever you want a variable and a coefficient, just write this. Don't write anything in between. Just write the coefficient and write the variable, and everybody will know what you mean. Okay. And there's other ways. The asterisk. 3 times 3 is 9. 3 there's x. It's not as common, but I use it when you're typing. Usually people use the asterisk. It's similar to that. Another way is 3 parentheses x, the same thing as the parentheses. The parentheses is just a way to separate your numbers. There's also, I can't talk. It could also be used to separate terms if you wanted to, but then if you overuse parentheses, there's no point in using them because then you just saturate your entire equation with parentheses and it just looks ugly again. So it's up to you. You have to look at it. Yeah, it can get very messy though. All right, so what are the factors of each term? So recall that the factors are numbers that are multiplied together, and factors with variables. You know how that is also possible. So let's expression again. What do you guys think? So you have 3x plus 2xy minus 2 times 3, which can be simplified, plus 4y over x. What do you guys think are the factors of each term? I mean, technically this has factors too, I guess. Yep, 2, 3. Okay. All right. So yeah, can you spot the factors? So basically, the factors in 3x are 3 times x. The factors in 2xy is 2 times x times y. 2 times 3 and 2 times 3, obviously. And 4 times y times 1 over x. That's how you do it. 4 times 1 over x is 4y over x. Hopefully you guys can see that, because yeah. It's the same thing as dividing by x, but technically it means 4y times 1 over x. That could get important in advanced algebra problems, so it's important that you spot that. When you're dividing by variable, you can just multiply by 1 over the variable. That should be that. Okay. And so we can answer all the questions related to this expression right here that I just made up in my head when I'm making this. So number 1, how many variables? Well, there's 2 variables, x and y. How many terms on this expression? There's 4 terms, 3x, 2xy, 2 times 3, and 4y over x. And what are the factors of each term? Well, we just covered that. 3 times x and 3x, 2 times x times y and 2xy, 2 times 3, and 4 times y times 1 over x and 4y over x. Any questions? So we know what terms are. We know variables and the factors of each term. This is important. This is pretty important for algebra. This is the basics of algebra. If you get this vocab down, then when you talk to people about this stuff, you'll be like, oh yeah, I know what you mean now. So, all right, moving on. Basics of algebra, combining like terms. So combining like terms is simple. It's pretty easy actually, but it's really important. So you combine like terms, it's almost like simplifying expressions. So let's say you had 2x plus 3x, right? Yeah, exactly. Whole plus whole. I've never heard that rule, but sure. So let's say 2x plus 3x, right? You can combine these terms together to create 5x. Why? Because they have the same variable. They're like terms. They're just like each other. So 2x plus 3x is equal to 5x. I should write that. That's important because it's like the distributive property. Yeah, I guess, yeah, sort of. Variable stuff with variable stuff, yeah. So this is important because sometimes when you're in the middle of algebra, sometimes the equation can be simplified further if you combine like terms, or if you're in the middle of it and you do a step that creates like terms, you can combine them. Huh. I mean, yeah, it is like that. I wouldn't teach it like that, but I mean, it's perfectly valid. It is like the distributive property because you can factor out the x. Notice how these both share the x, so you can factor it out, which equals 5x. I wouldn't teach it like that because I'm going to teach you guys distributive distributive property later, a couple slides down, but yeah. So you add the numbers together to get a new number factor, a new coefficient, yes. So when you're adding like terms, you combine the coefficients, you add the coefficients. When you're subtracting, so if you had 2x minus 3x, that'd be negative x, right? Only have the same variable, yes. Now keep in mind, you cannot do 2x squared plus 3x. You can't combine these two. These two are not combinable because you have an x squared versus an x. That's not combinable. Keep that in mind. I already know what the distributive property is. Good for you, son. Good for you. Why? Because the x squared and x, they technically mean different things. Because remember, this is 2 times x plus 3 times x. Totally different things. Not totally, but they mean different things. So they have to have the same variable, same exponent, all that stuff. Okay. So combinable terms. I don't know if you need to follow this guideline because once you practice this enough, you'll see it like just like that, like instantly. So 2 or more terms with the same variable can be combined. So 2x, 3x, both share x. 2 or more terms without any variable can also be combined. So it's just basically doing numbers. So 2 plus 3, you combine like terms, 5. Those are technically like terms, 2 plus 3. So yeah, we just simply do whatever operation is shown to us. And the last part is 2 or more terms that can be simplified. So what I mean by that is, say you had 2y divided by y. You could just cancel out the y's, right? And you're just left with 2, right? The y's cancel out. Or 2 times 3 plus 4x is just 6 plus 4x. So that's what I mean. And yeah, it's just way better once you see it, you'll be able to get it down super fast. And it's just way better. But you could do 2 squared and add the 2 squared and add the 3, and you get a new number factor. And they also follow the rules of the same variable, I mean. I'm going to say no straight up because I don't know what you're trying to ask, but no. There's no 2 squared. This is 2x squared. So you cannot, let me erase this. So you could do 2x plus 3x. They both have x, right? X is the first. X is first. So you can do 5x. But you cannot do 2x squared. This means 2 times x times x. The 2 is not being squared at all. The 2 is still 2. It's the coefficient of 2 still. Plus 3x. Now this is x to the first power, right? These aren't like terms anymore. These two, 3x and 2x squared aren't like terms any longer because the x squared changes everything. But why can't you? Because the x squared makes it no longer like terms. That's why you can't. If I had 2x squared plus 3x squared, then I can do it. I can do 5x squared equals 5x squared. That's perfectly valid. In fact, that's true. And 2x plus 3x, there are 2 x's, not 1x. Yeah, there are 2 x's, but then you can combine them together because they're like terms. That's the whole point. That's the whole point of combining like terms. You want to simplify it further because you can do less work that way. How and why? I just showed you right here. Okay, so if they have the same variable, they can be combined, right? So you had 2x plus 3x. You just add the coefficients together to get 5x. Here, let's do a different example. Let's say you had 4y minus 3y plus 2y, right? They all share y, right? You can determine they all share y. And when you combine like terms, you can just go any direction you want. So 4y minus 3y would create 1y, which is just y, because 4 minus 3, you just subtract the coefficients, plus 2y creates 3y, right? Yeah, do 4 plus 3, no, 4 minus 3, yeah, but don't shoot me. Does that make more sense? Sorry. So 2 variables, and then if you have 4y minus 3y plus 2y plus 6 minus 6 plus 6, these two just cancel and you combine like terms like that. Because this is the second part. 2 or more terms without any variable can be combined. You just combine this like terms right here. Okay. And we'll do a couple examples. This should be, once you practice this, you should be able to get this down very fast. And then the cumulative property and stuff like that, yeah. And identity property, you don't have to know that. Let's go. All right, here's some practice. So simplify each expression by combining like terms or simplifying each term. And this one's a little tricky, not really. And this part x will be an exponent. It's a little hint. So let's do the first one. I'll do the first one with you guys. You guys aren't clear. Okay, number 1. So you have 4x times 2, right? Well, 2 times, it's the same thing as 2 times 4x. Oh, I should have done that. Whoops. 2 times 4x, right? Minus x plus 16y. Now you can leave this alone for now. The minus x plus 16y, you can leave alone because they don't have like variables. But this one, you just simply multiply the coefficient together. So you would get 8x minus x plus 16y, right? And then the 8x minus x, this is technically 1x. So 8 minus 1 is 7. So it would be 7x plus 16y. So you do it. But there are no y in the 6. Yeah, you leave the y alone then. Just leave it there. So number 1 is 7x plus 16y. Remember, you can multiply the coefficients and it'll be fine. All right, let's try number 2. Okay, so number 2 is 4y over 2 plus y minus 9x times x. Well, this straight off the bat is 9x squared because x, that's the definition of x squared. X squared is x times itself 2 times. Then the 4 divided by 2 is just simply 2. So 2y plus y minus 9x squared. And then you can combine these two to give you 3y minus 9x squared. That's it. And you can't combine that any further because you have an x squared and you have a y. But what is y? You don't care about what is y. You don't need to know what is y. Y is a variable. You don't need to care. If m was in the power of 2, it would be a delicious quadratic to factor. What m? Oh. No, wait, what? No, it's fine. You can factor this already. Well, actually, it's not even, you don't know if it's perfect. But then, because you have a 100v squared, minus plus 7mv minus 12m. That's perfect of quadratic. Doesn't MV mean music video? Yeah, in everyday terms, yeah. But this is just variables. Okay, I guess I'll leave number 3 to you guys. This part is super duper easy to simplify. But yeah, you can factor this out. I mean, this follows the conventions of quadratic formula, if I'm not mistaken. Oh, it doesn't, huh? Because it's 2 variables. Never mind. That is wrong, Jenny. I'll give you that. That is very wrong. Can you do z divided by z divided by z? Then you would have 3 different z's. Here, I'll rewrite this. This is z over 3z plus 14x minus 14x, which you should see straight off the bat just cancels each other out because 14 minus 14 is 0, plus y over 2 plus y over 2. Ah, I see, okay. Think of z as a number, right? If you had z over z, that would equal 1, right? Because they both cancel each other out. Because let's say z was 4. So you have 4 over 4, which is just 1. So they just cancel each other out, which you'd be left with 1/3. And then you just got to simplify this. But the z over 3z really muddled me. Huh? I'm trying to challenge you. Okay. I'm going to move on, but yes. But yeah, because this is, I mean, if you guys have any questions, let's see. I technically did it all for you guys. So just 1. Yeah, no, well, if z over z, if you had that would equal 1. But then since you have the 3 right here, if z over 3z, the z's cancel, but the 3 stays, so you get 1/3. So yeah, let's see. How do you get 4? Number 4? Oh, I didn't do it right. Whatever. Well, I did it right, but I didn't write it in the right order. Yeah, close enough, Catherine. Just take out the equals, put in plus. It's positive. How do you do it? Okay, so notice that the 3mv and 4mv, they share the like variables of mv together, but you can't mess with the 12m or negative 12m because it's only 1m, right? He doesn't share it with anything else. So this you can do 3 plus 4. 3mv plus 4mv would be 7mv, right? Minus 12m. And then remember, this is v times v is v squared. Same thing as v squared. So it would be plus 100 v squared. And then if you want to write it properly, 100 v squared plus 7mv minus 12m. And none of these other terms share v squared. So you have to leave this alone. I hope that makes sense. You have to do a lot more practice. Okay, let's move on. All right, so what are the coefficients of each equation and what are the terms of each expression? Well, you can see that the terms are 7, 8z, and 14y. The coefficient 8 and 14 for this one. Yeah, I'll just do this real quickly, guys. Coefficient is 3. You get 4 right here because 3 times z times y. Remember, coefficients are numbers. Remember, coefficients are always numbers. And the terms are 3zy and 4x, boxer terms. You have 1444 is one term, and 1453 times b is your coefficient. So 1453 is your coefficient of b. This one has no coefficients, and this is all one big term because you can simplify it. And x squared plus y squared equals z squared. Well, there's no coefficient. Technical coefficients are 1. And the terms is x squared and y squared. And if you want to do x as multiplication, x times x plus y times y. Like that. Pretty easy. Okay. This is wrong. Technically, the coefficients are 1, but there's no non-1 coefficients. Okay. And coefficients can't be 0 because then 0 times anything, even variables, is 0. So yeah. Can you do a different variable? But why? I like my variables. It doesn't change the question, right? Okay. Formulas, right. So this is, you guys know area. Today we talk about area. You guys know area. Let's see, can you do a different rule for that? Yeah, you could do it. A squared plus b squared. X squared plus y squared. Those two are the most common way to do Pythagorean theorem. Yeah. Got piano going on. Okay. Because Asian. I'm joking. Well, yeah. Formula is an equation that uses mathematical symbols and stands for a factor rule that can be used. So usually has an equal sign. In fact, I think most likely 99.9% of the time, it has an equal sign. 2 or more variables, which we don't know the value of. That's part of it. And can also not have the equal sign and be an expression, but it's more common where you have the equal sign. So use express the relationship between different variables. So here's examples. Most common one, a squared plus b squared equals c squared, Pythagorean theorem. This relates, if you had a right triangle, it relates the square of the hypotenuse is equal to the sum of the square of the long leg times plus the square of the bottom leg. It just relates a and b to c. That's all you need to know, basically. Let's erase that. And when you use formulas, you try to figure out what each variable means and equals, and then you just substitute it in, or we like to call it, plug it in. So you find out what the numbers are for the variables, and you just plug in the numbers. No one says substitution, okay? Yeah, I'm gonna skip that. So let's try using it. When does the equation not have an equal sign? That's not an equation then. The definition of equation needs to have an equal sign because it has the word equation. If you spell it out, equation, it has the word equal in it. Equation equals is like that. See that? It has the words equals in it. Equations must have equal sign. That's what makes it an equation. That's the point. So never, technically never. No, for formula doesn't have to have an equation, equal sign. 99.9% of the time it does for a formula, but not for an equation 100% of the time. You must. Okay, yeah. So yeah, this is easy. This is, you guys already know it. So solve 3x plus 4 if x equals 2. So you know what x equals now because I just told you if x equals 2. So then you just plug in 2 for x and you do 3 times 2 plus 4, which is 6 plus 4, just 10. Yeah. When does the formula not have an equal sign then? If you don't want it, for example, like here's the formula for kinetic energy, 1/2 mv squared. So m is mass, v is velocity. You could say this, Ke, kinetic energy, is equal to 1/2 mv squared, or just say 1/2 mv squared. That's it. You don't have to say anything more. This is an expression. This is an equation. But they're both formulas. So yeah. Okay, it's the same thing here. Y equals 4, x equals 3, and z equals 1. So you know the three variables. You can do this for multiple variables. And you just plug it all in. So x goes to 3, z goes to 1, and 4 goes to y. Right? So you plug it in, so it'd be 2 times 3 plus 7 times 4 minus 4 times 1, which is 6 plus 28 minus 4, which is 30. And you guys get the idea, right? Y equals 3, x equals 1, you plug it in. Right? 3 times 1 divided by 3 is just 1, because the 3's cancel. Yeah. Okay. You guys can do this real fast, I guess. Just do these two. Real fast. Yeah.
Wait, what do you mean? Then doesn't that mean there are 3 t's? I don't get it.
So you just do it multiple times. You rinse and repeat. So if t equals 5, I should say or t equals 17, or t equals 100, right? Because there's just different scenarios for how many tickets you sell.
I don't understand.
Okay, so simply plug in t equals 5, right?
Yeah.
And then when you interpret the question, so a movie theater sells tickets at price of $10.50 each, right? And then t is the number of tickets sold, right? So when you interpret the question, if t equals 5, that means selling 5 tickets will give you 10.50 times 5 amount of money. That's basically what that means.
Oh, okay.
And then if t equals 17, it'd be 10.50 times 17. How much money would you make? And then if t equals 100, how much money would you make? 1,050, because you know the trick. So if you sold 100 tickets, you would make $1,050. That's what it basically, simply, most simple form.
Okay.
I'm gonna zoom by this. So this one, t equals 5. Yeah, okay, you guys get the idea, right? So just plug in the numbers for t. I'm gonna zoom by this because we have a little bit more to go. And if you're publishing 10,000 people, every year the population grows by 879 every year, per year. So if you use y for years, you have 10,000, your expression would be 10,000 plus 879 times y for the population.
But the problem is that what happens if but a city can't just get that much every year. It can't be continuous like that because that's not real life.
That's true. I made these questions though, so deal with it. But yeah, exponential growth, if it's real life, exponential growth is a thing, and then carrying capacity and all that stuff. So your graph would look like that. Yeah. There you go. Okay. Area, you guys know area, so here we go. So area is the number of square units needed to cover a figure or a shape without any gaps or overlaps. So area is two-dimensional, which uses 2 measurements. So it uses 2-dimensional shapes, 2D shapes. And you only need to know about squares, rectangles, parallelograms, these are the same, trapezoids, and circles. And note, when you use the area formula, or you solve the area formula, you have to use your answer in units squared, right? So it'd be inches squared, centimeters squared, whatever. This is important. It has to be squared. Okay, so here's just a little preview. You guys can see.
Hi, R. Ping Fong.
Wait, let's see. Is it t plus 1? Close, you're close. Yeah. Okay, so area of a square everybody knows. A equals s squared. So if s was your side length, you just square it, right? So if you had a square with 2, remember squares, all 4 sides have the same measurement. Okay, so that's how squares work. All 4 sides are the same. That's a square. So the area of this square is 4 units squared.
What if you use fractions or decimals?
You could do that. Well, you want to? That's a pain. I'm just looking to see if you guys understand. I don't make it like super challenging.
On like what, first grade, second grade, something?
What?
Area in like first or second grade.
Oh yeah, I just teach you guys again. All right, so rectangles or parallelograms, technically the same thing. It's base times height or length times width. So I've never seen it as base times height on a rectangle, but that makes sense. So parallelograms are slanted basically, but they're the same thing as a rectangle Because rectangle is 90 degrees. This is however many degrees.
Just top it off and bring it over there. Duh.
So yeah, base times height, simple stuff. You guys know that, right? And make sure you use the perpendicular height when you're doing parallelogram. How do you get area of a circle? We will get there soon. All right, triangle. Triangle, all you just need to know is half the area of rectangle, because this is a rectangle, it's a triangle. Everybody knows that. And base times height divided by 2. That's it. Trapezoid. Do you guys know area of trapezoid? They don't teach you this much at school, but it's pretty important. So trapezoid is base 1 times half of a base. That works too. It's just half the area. It's the same thing.
Base 1 plus base 2 times height divided by 2. Such a complex.
Yeah, so sort of, not really. Times height divided by 2. So if you had your H, your A and B, so this is base 1, this is base 2. Add them together, you multiply by the height, and you divide everything by 2. So yeah, this is a much better rendition.
I want to see the circles.
Okay, circle's not that hard, guys. All right, circle.
Yes.
Area of a circle. Pi r squared.
Pi r.
Pi r squared, yeah. And radius is half the diameter. So technically, y, ooh. This should be squared. Y, yeah, that's.
Since pi is infinite, and a circle is also infinite, why not use an infinite number with an infinite?
You cut this like circle into.
You see, just the Q's, so that's later. That's later. Okay. The area of circle. Why is it that you have to look on YouTube? Because I know why, but it'll take more time than we have. I'll just tell you is imagine you have an infinite amount of triangles, like super duper small, like smaller than this, like really small triangles, right? And then you unwrap the circle, right? And basically the amount of these super small triangles you have, if you unwrap the circle, it gets closer and closer to a rectangle, right? And the rectangle has dimensions. The rectangle would have dimensions pi and r squared. It's a lot more than that. What do you mean? Oh, why? It's calculus. I do calculus for that. So yes. So pi r squared, that's all you need to know. Area of a circle is pi r squared. And if pi is a rational number, many people use 3.14. And some people just leave it in terms of pi. In fact, you should start learning how to do that. Unless the question tells you not to, start learning how to do that. So area of a circle of radius of 3, 9 pi units squared. Because it's squared. Stuff, yeah. All right, so here's the summary. All your area formulas. So square is side squared. Rectangle or parallelogram is base times height. Triangle is base times height divided by 2. Trapezoid is base 1 plus base 2 times height divided by 2, or 1/2 times base 1 plus base 2 times height. And the circle is pi r squared. This is the easiest to remember, pi r squared, because then circumference is 2 pi r. So a lot of people get confused between these two, but honestly, it's the easiest to understand. And then volume of a sphere is 4/3 pi r cubed. And that's also another proof that you have to use calculus for. You don't have to.
I don't want to learn calculus. It seems hard.
Okay, good. I got you. I mean, you can look these up all online on the internet if you're ever unsure, if you ever don't remember. In fact, I erased this part because you don't need to know about that yet. I mean, like the volume of a cube, you just add another dimension, right? It's just side cubed. Because squares go to cubes. So it's not that hard. It's not that much harder. Because this is just, this is like a rectangular prism. You just do volume is length times width times height, right? You just add another dimension, which is why volume is 3-dimensional, area is 2-dimensional. How about a volume of a ball? Assuming the ball is a sphere, I just told you 4/3 pi r cubed. That's a 3. Assuming the ball's a sphere. Assuming.
But like, what if the ball is like one of those oval spheres? One of like the oval spheres.
Like a football?
Yeah.
I wouldn't know exactly then. That means you had to because here with circular shapes, 3D shapes, finding the volume of it's not that fun. And if anything, it's a very, very close approximation. This is exact. Well, pi is mixed approximation, but this is exact because we proved it. But if it feels like an irregular oval type thing, then it'd be a lot tougher. Then I wouldn't know personally. You have to use calculus and you have to use other stuff. But you could just do displacement, water displacement method in science. You could do that. Area of an oval? You don't need to know that. I don't know it personally. And no one cares about ovals. Come on. Here, just look it up right now. You can look up online. Area of an oval. Oh. So area is a times b times pi, because ovals have a focus. There's a focus right here, and there's the radius. Yeah, so the b is the length from the minor radius, major. Yeah, you don't need to know that. My best friend's an oval. What is, LW is length times width, and base times height. Interchangeable, they mean the same thing. So yeah. All right. Find the area of the following shapes, and the drawings are not to scale, by the way. Should be really easy. This is a square, so this is just 9 squared. Just squared. Just simplify that. Yeah. This is a rectangle, this is a rectangle, this is a trapezoid. I'll say this is 2 kilometers right here. I forgot to add that. 2 kilometers. Yep. Everything else is good. And then once we do this, you guys are free to go. I'll give you the answers if you need them.
Wait, what's that 20 kilometers?
What's the what?
On that parallelogram.
Oh. Yeah, sure, I'll take it, Catherine. But yeah, prefer to keep your answers in pi, in terms of pi. So yeah, you had the right idea. This is just, yeah. Keep the pi, don't plug in anything. I should have specified that. That's okay. You don't really get how to do triangle? Okay, I'll help you. All right, so triangle is base times height times 2, or divided by 2, sorry. So you have your base, which is 12 centimeters. Base means bottom, B for base, B for bottom. And your height is 4 centimeters, right? So it'd be 12 times 4 divided by 2, which is 48 divided by 2, which equals 24 centimeters squared. That's simple.
Like the parallelogram that you put in there doesn't really make sense because like the bottom,
yeah, my bad.
The top is like 2 kilometers. What?
What are you talking about? I don't know what you're talking about.
Well, I just saw you
What are you talking about? Yeah, that's my bad. Sorry.
you remove it. Why? It's like 10 times. It's like down to the pixel, the exact same. But when you write it down, it's like 10 times smaller.
Really?
Because
Really?
you wrote 20 for the top and for the bottom and 2 for the top. So 20 is 10 times.
I have no clue what you guys are talking about at all.
You literally just erased it. Like,
What are you talking about, guys?
You erased.
What are you talking about? What are you talking about? I guess I'll let units slide for now, but obviously make sure you include your units. because this is a thingy problem. Yeah, I don't know if you guys, kilometers squared, but yes, you have the right number. Remember, square your units, because this is area, 2 dimensions. There's 2 different dimensions. But I don't know what you guys are talking about. What 2 kilometers? That's my bad. All right, I'll give you guys like a couple more minutes, and then once you see the answers, you're free to go. Or if once you're done doing these questions, if you don't want to see the answers because you know you got it, then you just go. But if you want to see the answers, stick around. And the circle might be a little different. I kept it in terms of pi, because that's what I was. When you get older, they tell you keep in terms of pi. Don't use 3.14. I'm like, okay. So yeah, I've been conditioned to do that for 4 years.
I don't like multiplying by 3.14 because it's just
You don't like what?
multiplying by 3.1.
I don't know what you said because I can't hear you, but I hope you like it in the future. I don't know. Oh man, I'm so excited for tomorrow. Perfect. I have no clue what you're typing. Oh my god, what is this? This cursed typing. All right, 1 more minute. I'll give you guys 1 more minute.
Hi teacher.
Yep.
This is kind of off topic, but how do you find the area of a triangle without knowing its height?
I don't think you can, because you need the height.
Oh.
Yeah, yeah.
The crickets are just.
I think you need the height. That's the point, because the formula for a triangle is base times height. You can, yeah, if you knew the area of a triangle, but you didn't know the height, but you knew the base, then obviously you could solve for the height. But since you don't know the area, then you don't know the height, you can't do it.
Wait, is it possible to be if you know like the slanted side, like if both of the slanted sides are equal and you know the bottom one, is it possible to figure it out?
Yes, it is. Yes, it is possible. Yes. Yes, that's a good observation, because assuming that the height bisects the triangle, right? And if you knew, say this is S and S, and this is B, assuming that the height bisects it because it's perpendicular to the base, then this would be B over 2 and B over 2, and it forms 2 right triangles. So yes, you could find the height, because then you can solve for the right triangle, because this would be.
Oh yeah, using the I forgot what it was called.
You can either use special right triangle properties, but if it's not a special right triangle, then you have to use inverse sines and cosines. That's You have to use inverse trig functions. But that's a very good observation.
Wait,
okay.
Can't you use the Pythagorean Theorem as well? Like.
Oh yeah, you could.
The slanted side is kind of like that, basically.
Yep, you could. That's a very good observation. Yep. So you have S, B over 2, and say this is X. So B over 2 squared plus X squared equals S squared, and you just solve for X. Yeah, that works.
Oh, okay. Thank you.
Yep. All right. Here are the answers. Left to right, top to bottom. Oh, they should have pi. I think, yeah, you guys had it right for the most part. So yeah. Yeah, that's a very good observation. Yes, you could do that, assuming that the height will bisect the triangle. It has to bisect it though, because then there's some triangles that is wonky. Yeah. I think it has to be isosceles in order to do that. Yep. See you guys. If you guys are done, hope you guys have a good rest of your day and or night and or evening, whatever.
Goodbye.
Goodbye.
Bye.
Mm-hmm. If you have any questions, just you could stick around. If you have no questions, I'm just gonna leave or end it. I'll leave it, end it. So if you have any questions, just stick around and ask me. A couple minutes. What is the Pythagorean theorem? Okay, that's first of all, that's not how you spell it. Pythagorean theorem. Pythagorean theorem. That's how you spell Pythagorean theorem. So the Pythagorean theorem is one of the most fundamental theorems. It's basically a rule of trigonometry, which is the study of triangles. And basically what it says, if you have a right triangle, right? You had side A, leg B, leg C, not leg C. This slanted side is called the hypotenuse. This, in a right triangle, the diagonal side, will always be the longest side of a right triangle, okay? If it's not the longest side, then either A, you don't have a triangle, you don't have like a real triangle, or B, it's not a right triangle, right? So it has to be the hypotenuse, this little diagonal, so let me change colors. This diagonal side is always the longest side in a right triangle, okay? So anyways, to the theorem. Pythagorean theorem says that A squared plus B squared equals C squared. So if I took the square of the side length of one leg, right? And I took the square of the side length of the other leg, it will equal the square of this, the length of the hypotenuse. That's what it means. And this is pretty useful because you can, if you have two sides of a right triangle, right? So like, say you knew A and you knew B, but you don't know what C is, well, you can use this to find C. Or if you knew what A and C was, and you don't know what B was, then you can change this equation around to do B squared equals C squared minus A squared. So you just rearrange it, and it's very flexible to find the other side lengths. Any other questions? Okay, I'll give you guys a couple of minutes if you have any questions. Otherwise, I'll just end the meeting. Why is number 254? It could be a mistake. Oh, that's a mistake. $120. Yeah, I changed these on the fly because I'm like, oh, these aren't as challenging as I thought it would be. So it's like, yeah. Is the O with the negative middle of the hypotenuse? Okay. I need to teach how to spell these words. Okay. Let's go white. Screen. Let's go black screen. Okay. So you have this. So this is the hypotenuse, HYPOTENUSE. This is called the legs, these two parts. leg. And what you're saying? Is the L with the negative in the middle of the hypotenuse? Oh, I was just circling things together just to show you easier. And so I guess another way you could write this is leg 1 squared. So it's like 1, like 2, plus leg 2 squared equals hypotenuse, HYP for short, squared. So that's another way of writing it, but most people write it as like this because it's the easiest. Any other questions? What is the 0t with the negative in the middle called? What do you mean by that? Never mind the t. What is? Oh, theta. Ah, you're talking about theta? Theta. Theta. That's for angles, yeah. I'm talking about this, theta? The 0 with the thing. It's got theta. Theta, yeah. It's just a variable. It's another variable. Usually we use it for angles. So like right here, this has angle theta. Yeah, you can leave whenever you want. I'm just sticking around for questions. Yep. Hey, have a good one. Have a good one. What are you sending me, Joseph? What is this? 1,552, 2,916. What is this? I don't know what that is, so. Or I don't know what you mean by that. Okay, any other questions? Oh, for the questions? The area questions? That is, wrong. Let's see. I will erase this real quick. Okay, so hold on. All right, so if we showed you, let's see. So this should be 81 inches squared. This should be 16 pi inches squared. I like to keep it pi. You can put 3.14 if you want. This should be, let's see, 120. Yeah, 120 inches squared. This should be 35 feet squared. That's a 5. That's a, hold on. Oh, hold on, give me 1 second. Ooh, okay. Okay. 35 feet squared. This is 18 times 14, which if I do real quick, 252 just squared. This is 100 kilometers squared. This is 110 yards squared. So 1. And this is 24 centimeters squared. Are you good? Okay, any other questions? Otherwise, I'll just end it. And yeah. Is leg 1 C or B? B is generally the legs. A, B, yeah, you can leave, yeah. That's what I said, yeah. I'm just here sticking around for questions. For triangle, so So disk A, B, C. Generally, this is how we do it. You can do like this too. B, A, C. It doesn't matter. We just do usually 99% of the time we do like that. A, B, C. And C will always be your hypotenuse, right? In this case, equals C squared. Remember, the two legs squared combined equals the square of the hypotenuse. And hypotenuse is always the longest side of a right triangle. Which, how do you know? It's whatever you label it as. You can call this anything. I don't know what you call it. You can do like this x, y, z, and you do y squared plus z squared equals x squared. This is however you isolate it. Which one is hypotenuse? It's always the diagonal side. This side that's slanted, that's not straight, because these two are straight, and then this is diagonal. This is hypotenuse. Always hypotenuse, no matter what. So here, let me show you other ways. You can write right triangles. So you can write right triangles like that. You can write a right triangle like that. Right triangle like that. Right one like that. Assume that's a 90-degree angle. Okay, I'm gonna write that better. What for all other kind of triangle? What about the other kind of triangles? That's a little different. The thing is, okay, but I'll just show you which ones are hypotenuses. How do you find the hypotenuse? Like how do you locate it, or how do you find the number? How do you find the number is Pythagorean Theorem, like I said. C squared. How do you locate it? Well, it's every slanted side. So this is the hypotenuse. I'll change my color actually. For other, no, okay. Oh, I should have clarified that. Only right triangles have hypotenuses. There's no such thing as a hypotenuse on like this triangle, like this basic triangle. There's no such thing. It's just a special name for the longest side of a right triangle. It's like only for right triangles, that's why. It's only meant for right triangles. So hypotenuse here. So notice how all these slides are slanted. These are all right triangles, these 5. And the hypotenuse is this slanted side right here. Notice that? So yeah, have any questions? But yeah, the reason why these basic triangles that you're like more used to seeing, like these ones, they don't have such thing called hypotenuse, because hypotenuse is only meant for right triangles. That's why. Okay, any other questions? If no other questions, I will end this meeting. Hope you guys have a good rest of your day / morning / night / evening. I will see you guys tomorrow. Peace.